Sample problem number 4, mixture of gases. So for sample problem number 4, we are given with 20 kg of flue gases formed per kilogram of fuel. In the combustion of fuel oil, how much is the excess air? So the formula for our excess air is given as y minus ycc over ycc times 100%. So we need to solve the value of y and ycc. So step 1, we solve for ycc. Since we have our fuel as C12H26, we just substitute to our equation for ycc. So our ycc is 18.5. The second step is to solve for y, but since we don't have the values for y in the given yet, so we need to solve for the air-fuel ratio from our equation. And from that, we find a way to solve for y. So the value of the air-fuel ratio based on the equation can be given as mass plus mass of air plus mass of the fuel is equals to mass of gas. So the products, which is gas, is just equals to the sum of the mass of air and fuel, assuming that there is a complete conversion of conservation of mass. So since we are given with the mass of gas per kilogram of fuel, so we are given with mass of gas per kilogram of fuel, so we need to manipulate this equation in such a way that we can solve for the air fuel. So if we divide all of this by mass of fuel, so this first term will become mass of air plus mass of the fuel. The second term will be 1, and the third term will be mass of gas plus mass divided by mass of the fuel. So from this, we can solve for the mass of air over mass of the fuel, or the air-fuel ratio. So that is mass of gas per kilogram of fuel, which is 20 minus 1. So our air-fuel ratio is 19. And then using another equation in terms of air-fuel ratio to solve for y, we know that air-fuel ratio can also be written in this format. So we know that it's just the number of, we know that y is the number of mole of oxygen, so that is y. So y plus 3.76y, which is the mole of nitrogen, times the molar mass, divided by 1 mole of fuel, and then the number of the molar mass of the fuel. So if we solve for this equation, simplify it, so this is the simplified version. So 137.85y divided by 170 is just equals to the air-fuel ratio. So we equate 19 to this equation so that we can solve for y. So we equate and then solve for y, so y is 23.431. And finally, since we already have y and ycc, we just substitute to our equation for excess air. So our excess air is 26.65%.